All right, what's up? Let's go over multiplying and dividing rational expressions. Okay, so feel free to pause the video and see if you can read these or just follow along. So the rule for multiplying rational expressions is the same idea as simplifying a single rational expression, right? The rules are the same. Step one, you always want to factor the numerator, the top, and denominator, bottom, if possible. Factor completely. Step two, you cancel any common factors, right? This is the simplifying method. And then lastly, once you've canceled out everything, you write it, combine into one fraction. Now, you don't put them back. You don't put the terms back together, right? You leave them factored, and you don't multiply it out. So, for example, here we have a term in the top, x plus 1. Well, this is 4 times x plus 1. In the bottom, we have 2 times x plus 1 times x plus 2. So the thing in the top, x plus 1, thing in the bottom, x plus 1. So these terms, right, because it's already factored, step 1 was done for you. So I'm demonstrating step number 2, right? You cancel out the common factors. So whatever factor was in the numerator and in the denominator, you basically cancel those out. Now, here's the thing. Every time something cancels, it leaves behind an invisible 1. So you don't necessarily have to write this down, but every time you cancel something out, there's a 1. It's not 0. So when you cancel something out, we get in the habit of saying, oh, there's nothing there. Well, technically there is something there. There's a 1 there. But when you cancel something out, it's not 0. That's the most important thing. Okay, so then this is going to be 4, right? Because 4 times 1 over what's left in the bottom, 2x, x plus 2, right? So don't multiply, leave them separate. One more thing actually can cancel. So this is going to be 2 and 4, right? A 2 in the bottom is going to cancel out with the 4 in the top. So 4 divided by 2, 2. So final answer, 2 over x plus 2. All right. So there it is. Those are the steps. You want to factor out all of the common factors, right? Anything that matches the obvious ones. And then sometimes you got to analyze the coefficients, the numbers in front. Okay, so let's get to the first problem. So we're going to multiply this out. So basically, we're going to factor and see if things cancel and then put it back together. So GCF, that's what we're trying to factor out. Now, the way I kind of do this, I start with the top left, top right, bottom right, pretty much in that order, right? It's 4 things that you're going to have to do. This is one of the reasons why we start off with factoring first, because now we're not teaching how to factor, we're just factoring. All right, so the common factor for the top left is 3x. This is going to go kind of quick. So, feel free to pause the video or see if you can convince yourself why it's 3x, right? There's a 3 and then there's an x. That's the most that I can take out. So leaving behind 1 minus x. If you check yourself real quick, you can plug it back in or distribute it, and then it would come out to 3x minus 3x squared. Okay. On the bottom left, it's a quadratic. So 2 numbers that multiply to make -5 that add up to 4. Well, 1 and 5. But it's negative. So which one's negative? So the small one, because when you add -1 to 5, it makes +4. So on the bottom, we get x minus 1, x plus 5. There it is. So this is the factored on the left. On the right, do the top. Again, numbers that multiply to make -20 that add up to 1. So when it adds up to 1, we want to have two numbers kind of close together, consecutive. So what I mean is 4 and 5. Right? 4 and 5 multiply to make 20, and then I can get a 1 to come out if I make the small one negative. So this means x minus 4, x plus 5. All right, bottom right, 3x. Nothing we can do there. Okay, I'm going to rewrite it so that these are all together. So 3x, 1 minus x, x minus 1, x plus 5, times x minus 4, x plus 5, all over 3x. Okay, now, normally, once you start to get nice at this, you won't be rewriting it. You would just be canceling things out. Right. But I wanted to kind of clean it up so you can kind of see what's happening. All right. Here's where we are. Okay. Some of the obvious things. Well, I'd say obvious things. But first off, when it comes to canceling, because we've already simplified this as much as we could, everything's factored. When it comes to canceling, you cancel from top to bottom, or you can cancel diagonally, but you can never ever cancel left to right. So if two things are in the top that could be canceled, you can't cancel when they're both things you want to cancel are in the numerator. Also, if it's in the denominator, you can't cancel them out. So you can only cancel top to bottom or diagonally. All right, with that being said, looking at some things that the obvious ones, well, there's a 3x here and a 3x here. So those are gone. There's an x plus 5, x plus 5. Those are gone. Now, you might say these look tempting to just say, yeah, they cancel, but they're actually different. So one of the tricks is that if you want to reverse, right, if you want to switch these two numbers, the way you do that is you pull out a negative. You factor out a negative, and this is now x minus 1. The 1 and the x switch places. Okay, now x minus 1 and x minus 1 can cancel. So there's going to be a lot of scratches and, canceling that's happening. You got to be able to kind of see through the clutter. So what's left behind? Well, can't forget about the negative, right? There's a negative definitely left behind. There's a x minus 4 left behind up top. And in the bottom, x plus 5. There it is. Something else to consider. It may be tempting to be like, oh, these x's cancel. Can't do it. Can't do it. Because it's not just x, right? It's x minus 4 and x plus 5, right? It's a binomial. It's two things being added or subtracted together. When there's an adding and subtracting that's happening, the only way that they can cancel is when the whole term, right? When the whole term matches. Yo, why did I miss that? X plus 5, x plus 5, x minus 1, x minus 1. Okay, so that changes a lot of things. It just changes the x plus 5 in the bottom. So what's left up top is negative x minus 4. And then in the denominator, everything canceled. 1, 1, 1. It's over 1. But you would never ever see that or write that. Right? We don't care about things being over 1. That's wild. My fault on that one. All right. So things cancel. When it cancels, it's just a 1. So final answer. But that was a good point, though, that I brought up about the x minus 4 and x plus 5. When there's terms, binomials, you can't just cross out the x and not the whatever's being added or subtracted to it. That's the point I'm trying to make. Okay, let's try it again. This one, I don't understand why the first examples always have these little like tricks in it. This 1 minus x, I guess it's good because when you want to switch x and whatever the number is, you just factor out a negative. The fact that we put that on the first one, it's kind of mean. Okay, let's look at the second one. Again, we're looking at top left, top right, bottom right. All right, GCF here. We got a 2. I can take out a 2. They each have an x. I can take out an x. Right. One side has x squared, but that's okay. There's an x left behind. This is going to be x minus 5. All right, bottom left. Bottom left at a glance looks like you can't factor anything out. However, this is a difference of squares. Right, this is a difference of squares. X squared minus 25. We all know that 25 is really 5 squared. So, what this means, right, this is 5 squared. So what this means is that x minus 5, x plus 5. At this point, you have to just be able to look at x squared minus 25 and just know, hey, yo, this is a difference of squares, right? It's a difference of squares, 5 squared. So say had this been another perfect square, like 16, well, then it would be 4, right? X minus 4, x plus 4. But it's not. It's 25, so it's 5. All right, that's the bottom left. Top right, x plus 3, can't do anything to it. Bottom right, 2x squared, again, that's already factored, can't do anything to it. So now, this is the simplified version. And we go to step 2. What can cancel? Are there any terms in the top that are in the bottom? Yes, there is. So let's see. X minus 5, x minus 5. That's the first thing I see. Okay. We have a 2 and a 2. Remember, you can go diagonal. You can go diagonal. We have an x in the top and x squared in the bottom. So 1x. Right, x squared. Remember, this is like x times x. And we're just taking out one of them. So normally what we do, or what I do, is I scratch that out and I know it's just a 1. Now, you got to remember, you can't lose the sight of an x. There's still an x in the bottom. Okay, we've canceled out everything we can. So this is going to equal. So what's left behind up top? So on the left-hand side, everything canceled. So it's just a 1. So I don't care about that side. X plus 3. In the bottom, we have x plus 5. Double check, am I sure? Yep. And then you might say, oh, you're done. But it's not. You can't forget about this x right here. There's one x in the bottom. Doesn't matter where the x goes. You can put the x in the back if you want. That's it. And as mentioned earlier, you can, like, it's very, very tempting, but you can't just cancel out the x's, right? That does not work. And it's because of this plus sign, right? X plus 3 locks the x and the 3 together, and the x is untouchable at that point, right? But here in the denominator, they're being multiplied. If there was another x up top, then yeah, sure, you could. But in this particular example, you cannot. We're done. All right, moving on. Okay, here's another good example. You might see something like this on an SAT type question. Notice the last two examples, there were pluses and minuses all over the place, right? X plus 3, X minus 4, 1 minus X. Okay, here, there are no pluses. So this is actually good news, right? This is actually ideal. I feel this should have been the first example we lead with. You can cancel out all the things on top and all the, as long as it's in the bottom. So essentially what I'm saying is you look at every individual thing. So let's start with the numbers, right? There's a 3 on top, 6 on top, 8 on bottom, 9 on bottom. Okay, so one way to do this, there's all different kinds of techniques, right? You can multiply everything straight across, right? Everything straight across this way. This would be 3 times 6, which is 18. X5 times X, right? You combine all the like terms. X5, when you multiply by X, you just add the exponents. So 5 plus 1 is 6. Y squared and Y squared. Y4, you add the exponents. Over. 8 times 9 is 72. X times X cubed. Again, you add the exponents. So 4. Y times Y, you add the exponents. Y squared. All right. This is a way. Once you combine the two into one, now you can start canceling out the variables and numbers, right? So look, so we have 6 x's on top, 4 x's on bottom. The 4 x's on bottom cancel out with 4 on the top. So that's leaving behind 2. Right? It's always top minus bottom. Top minus bottom. If you remember exponent properties, right? You could do 6 minus 4. I think of it as just canceling it out, right? So there's 2 y's in the bottom, 4 y's up top. So you can take away 2. Okay. 18 on top, 72 on bottom. So one way to do this, if we divide top by 9, we're going to get 2. Divide the bottom by 9, we're going to get 8. Divide these numbers. Divide that by 2, you get 1. By 8, you get 4. So, final answer is going to be, what's on top? X squared, Y squared. On the bottom, everything canceled but the 4. Okay, this is one method. I think it's not bad, right? It's not bad. There are other techniques. One way, here, look, I'll show you. Sometimes rewriting it or, right, putting one extra step by multiplying it out. Let's see, what's the next example look like? No, I'll do it here. So what I'm saying is, here, look, I'm gonna erase this. Hopefully you've already written down. If not, you can always go back. Okay, so before we know what the answer is, we'll keep it off to the side. One way to do this is saying, okay, if I start with the numbers, let's cancel this out. So here's a 3. That's going to make this a 3, right? Because 9 divided by 3. You can cancel out, this 3 and this 6. 6 divided by 3 is 2. Finally, 2 and 8 make 4. So this is one way, but it's going to get real messy. But if you're nice, you can kind of like see through it. In the denominator, here's an x. So I'm going to cancel out one x in the top, make that 4. I guess to make it a little bit nicer, there's an x in the bottom and one x in top, right on the right. It doesn't matter where the x comes from. The point is the x's cancel out. One x on top, one x on bottom. All right. There are 2 y's in the bottom. So I'm going to cancel out both y's with 2 y's up top. So that goes away. We're almost there. Last thing on the bottom, there are 3 x's. There's still 5 x's left up top. So if I take out all 3 in the bottom, that's going to leave behind 2. So kind of seeing through the clutter, up top in the numerator, we have x squared, y squared, and the denominator, we're left with a 4. And that's exactly what we got the first time. So you could either rewrite it by combining them and then canceling top to bottom, which there's nothing wrong with that. You know, it's respectable. Or you could just start canceling things out right away, right? It's completely up to you. Right, when it comes to choosing techniques, it's whatever's the fastest, right? You want to be efficient, right? You don't want to spend all day doing double the work. Okay. Here we have number 4. So again, we're going to simplify this the best we can by factoring. Top left, x plus 5, nothing we could do. Bottom left, 4x minus 16, I could just factor out a 4. This leaves behind x minus 4. Top right, I'm going to take out a 2. So 2, right, because 2 and 32. X squared minus 16. So here, right away I notice x squared minus 16. I trained myself to see a difference of squares, right? X squared minus a perfect square, which in this case 16 is a perfect square. So this is actually going to be x minus 4, x plus 4. Hopefully you saw that. All right, here's your chance. On the bottom right, x squared minus 25. But like we talked about this, this is x minus 5, x plus 5. Okay, everything is fully factored. The one thing I would say though, you kind of want to disregard this one right here, right? Because we canceled it out, right? Like we had to break it down even further. All right, and then obviously don't forget about the 2. Okay, so let's start looking. What can cancel? Start slashing at things. X minus 4, x minus 4, x plus 5, x plus 5. The 2 and the 4 leaves behind another 2. Okay, that's it. So this is equal to what's left in the numerator. There's all these slashes everywhere. What the heck's going on? It's this guy right here. That's the only thing left in the top. X plus 4. And the denominator, what's left? This 2 and this piece right here. So 2, x minus 5. You might have to watch that one a couple times so you can kind of see it. Once you see it, you can't unsee it. Fortunately. But the key is to see it. You got to see it. Okay. That's the front. Let's go to the back. So now, this is front page. This is multiplying. I said we're going to divide next. So when you're dividing, there are all these little different methods, right? One of the methods that really sticks is when you're multiplying, when you're dividing rational expressions, you always flip the second one. You always flip the second one. However, the acronym we use is keep, change, flip, right? You keep the first one. You change the symbol from division to multiplication, and then you flip the second one. So instead of C over D, it's D over C, and then you multiply. So now here is a very, very important note. If it's not already here. Yeah, it's not. Okay. There's a very important note. cancel things after flipping. So you keep, change, flip, and then cancel, right? Never, ever, ever cancel things out and then start trying to flip things, right? It's keep the first, change the multiplication, flip the second, and now start canceling things out, right? That's the order. So let's try it. So I'm keeping the first one. I really hate to rewrite because sometimes when you rewrite it wrong. And I know all about rewriting things wrong. So we keep the first term, change it to multiplication, flip the second one. X squared minus 11x plus 30 over x squared minus 6x. So there it is. Keep, change, flip. All right. So now this is the original, like, this is the problem that we have to deal with, right? This is what we got to do. This is essentially like the front page. This is literally at the front page now. Like we've spent the last 26 minutes talking about how to do this. So let's shine. So this is top left, 7x, nothing we could do. Bottom left, 2x minus 10. 2 and 10, those are both even numbers, so I can take out a 2. X minus 5. Okay, top right. 2 numbers that multiply to make 30 that somehow make 11, negative 11. So 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. So 5 and 6. 5 and 6 make 30. However, can I make an 11? I can. Both of these have to be negative, right? Because negative times negative is positive, and negative 5 plus negative 6 is negative 11. So up here, top right, we have x minus 5, x minus 6. Okay, bottom right. They both have x's, so I can take out an x. What's left behind? X minus 6. Okay. Do we want to rewrite? Or do we want to just start canceling things? Like, I just want to start canceling things. Like, that's, I mean, like, why not? Like, why rewrite it and risk writing something wrong? So, what can cancel top to bottom or diagonally? Never, ever left to right. So, off the bat, I see x and x. Or just get those out the way. X minus 5, x minus 5, x minus 6, x minus 6. So what is left behind? Up top, just a 7. That's the only thing left behind. 7 over what's in the denominator? The only thing left is a 2. My goodness. So what we find is that if you plug in, not if you plug in, but if you take this and you divide it by this, you get 7/2. 7/2 is the answer. Okay. Let's look at number 2 for division. All right, this one looks kind of weird. So let's keep the front one. So we keep this guy. We change this to multiplication. Right, this is times. I mean, if you want to use a little x, you could, but sometimes we use x's for variables. We just use a dot. Right, times. We flip the second one. Okay, so it's like, how do you flip this? Well, first understand that anything that's not a fraction can be written as a fraction as being over 1. This is 3x squared plus 5x over 1. Now, I want to flip this. So it's going to be 1 over 3x squared plus 5x. So really, we say under 1. Right? It took the over 1 and you flipped it. Now, you can rewrite it all. There's nothing wrong with rewriting it. I'm just using this to my advantage. I know it's going to be under 1. That's what happens when you flip it. Okay. Now let's start simplifying. Okay. I'm just going to come out right and say it. You cannot do this, right? You cannot cancel out an x squared and x squared when there's all this plus and minus stuff that's happening, right? If these were not here, then 1000% you could do this, but it's not the case. Okay, we have to factor the top left. The way we do this 6 in front is messing things up, right? I'm not going to go into how or the why. Just, I know I need to factor it. We're going to use what's called the slide and divide method. Right? You slide the 5 or you slide the 6 over, so you multiply. So really this is going to be x squared plus x, whatever 6 times 15 is. 6 times 5 is 30. Carry the 3, 90. So this is what we need to factor. So what two numbers multiply to make negative 90 that somehow add up to 1? Okay, I need it to add up to 1. So that means they need to be consecutive, like back to back. 10 times 10 is 100. 10 times 11, so it's smaller than that. 9 times 10. 9 times 10 is 90. So 9 times 10. One of them needs to be negative, the small one. So this is going to be in the numerator. This one, because I'm getting scrunched up here, I am going to rewrite it. So the top is going to be x minus 9, x plus 10. That's the numerator. Over 4x squared. Times. Okay, what can we factor out here? In the denominator, the only thing that's common to both is just 1x. So x, 3x plus 5. This is all under 1. This is a mean problem. This is a mean problem. Because, okay. There's something I didn't do. There's something I did not do. X minus 9, x plus 10. The most forgotten about part when you do slide and divide method is the divide part. You have to divide by 6. Whatever it is that you slid over to multiply, you have to divide that number, excuse me, back out. So, can we multiply or can we simplify this? This is going to be 3 over 2. This is going to be 5 over 3, right? Half of those. And then whatever is left in the denominator, you move in front of the x. I know if this is your first time seeing this, this is a very unique way of factoring, but it is very, very effective. So this is really 2x minus 3 and 3x plus 5. That's the numerator. That's what has to go over here. 2x minus 3, 3x plus 5. Okay, everything is fully factored. So, what can cancel top to bottom, and diagonally. So first off, let me show you what you can't do. You can't be like, oh, X and X, right? Because they're both on the bottom. That doesn't work that way. One has to be up top and one has to be in the bottom. So the only thing I see, 3x plus 5, 3x plus 5. So final answer is going to be 2x minus 3, right? Because that's really times 1 over 4. Add the exponents, 3, x3. Okay. We got 2 more. We're almost there. Okay, let's see if we can get a little bit quicker with this. How can we speed things up, right? You know, once you start to speed up, you start to make mistakes. But, you know, how will we ever grow and get better? So keep, change, flip. So keep, change, flip. So right now, don't get confused. That's gone. Right. I mean, we just verify real quick. Yep. It works. Okay. So don't look at that. So we multiply. Now, I'm not going to rewrite this anymore. I'm just going to start canceling things out. Like hopefully you can get it by now. Top to bottom, diagonal. You know what? Let's just rewrite it. Well, you know what? Let's not. Can you see it? Like, right? Can you see that there's 4 y's in the bottom, and how many y's are on top? 3 plus 3 is 6. There's 6 y's up top, 4 y's in bottom. You can cancel out. You can cancel this out. I'm going to take away all 4. Now I got to take away 4 from the top. I'm going to take away all 3 of these, and I'm going to take 1 away from this, leaving behind 2. Right? Like, this is what you got to be able to do. There are 2 x's in top. So I'm going to cancel those out with 2 x's in the bottom. Well, here's 1. I'm going to take 1 away from this, making 6. And now the numbers. 5 goes into 30 6 times. Right? Because 30 divided by 5 is 6. Okay. Put it all together. Can we see through the chicken scratch? This is going to be what's left up top. Y squared over what's left in the bottom. There's a 6 and x to the 6th. Right, it was this guy, and this guy. Okay. Number 4. Is the last one? All right, it's the last one. So let's see. Can we do it? Change it to multiplication. Flip the right hand side. 2 x minus 4 over x. Don't care about this anymore. Okay. Now, this is tempting, right? This is tempting. Those cannot cancel. But there is an x here, and there's 2 x's up top, because I can go diagonally, and now there's just 1 x up top. So put it all together. 2 times 8 is 16. There's still an x up top. There's still an x minus 4 up top. All over. What's in the bottom? X plus 4. There it is, guys. That's it. We did it. All right. Hopefully this helps you out. See you guys in the next video where we'll add and subtract. rational expressions. Catch you guys in the next video.